Swayam Prabha. Digital India. Educated India.
Welcome back. So yesterday we were talking about the example from US on the Denali fault. So this is one of the best example which I told in the last lecture also, that the geologist and the paleoseismologist, they took up a detailed study and then how they saved the pipeline. Okay. So this is the way how one can minimize the hazard. So this earthquake was in 2002 along a Denali fault, and then fault is close to the plate boundary between Pacific and North American plate. So investigation revealed that the fault may move by about 20 feet, and when the earthquake occurred it moved by 18 feet, and the pipeline did not face any problems or damage related to that. So this is the after the earthquake photograph was taken, where you can see clearly the zigzag form of the pipeline, which was because of the fault movement, and of course also due to the ground shaking. So the pipe was made flexible, the material was differently used, and to withstand the movement as well as ground shaking. So as I discussed in one of the slides, that in India, if we take, we have like 4 zones which are been like zone 5 to zone 2, where zone 2 is low damage risk zone, and then we are having 3 moderate damage risk zone, then 4 high damage risk zone, and very high damage risk zone. So this zonation, I would say it is a macro zonation. So as we discussed in one of the previous slides, that India, if we take as a whole in terms of the earthquake hazard, this is what we have, the macro zonation on a very large regional scale. The India has been divided into 4 zones. We will try to put in very like high resolution or blown up image when we are putting up the slides and all that online, but if you look at the color variation is very clear. Now the color variation, the darker color which I am pointing out here is zone 5. So you can see this over here, that is the northeast, and then we are moving along this play area in the northern part, northwest part. This whole region is the Himalayan belt, and apart from the Himalayan belt, in the southern side or the western side, we are having the Kutch and some locations around the Andaman and Nicobar area. So this all are in zone 5, and we have in total 4 zones, zone 5 to zone 2. Zone 5 is very high damage risk zone, and then zone 4 is high damage risk zone with slightly lighter color than what you are having, the reddish color here. So lighter color is over here where I am putting the pointer. This all are in zone 4, and then coming to the zone 3. Zone 3 is probably this is zone 3 actually. This is zone 3 which we are putting here right now. Zone 4 is slightly close to the front, but if you look at the red, the color combination, the reddish one is over here, and then slightly red, lighter red is partly somewhere seen here, that is in the Indo-Gangetic plain, and then comes down to zone 3, which is moderate damage risk zone. So this slightly more lighter color here is all zone 3. But one thing which I feel is that still we don't have the very good data from this region. Okay, that is the Narmada zone area, which partly falls in Gujarat and then goes in Madhya Pradesh. We don't have the good data in terms of the historical earthquakes, but this zone will also be considered, either it will fall in 4 or 5. If we get more data on that. Okay. So we can keep improving the zonation map if we are having more data available with us, or we incorporate that data or generate that data considering or doing more research in this region along the fault lines. So there is a very important fault line which runs here, which is termed as Narmada Zone fault or Narmada Zone lineament. So along this there was an earthquake of 1996 or so. There was a Jabalpur earthquake in this, but that can, I'm not very sure about that year, but yes, of course there was a moderate earthquake in this region, and that is definitely a matter of concern for us, that whether this zone is capable of triggering the large magnitude earthquakes in near future or not. Other than that, if we come down to this place, again we have the two zones with the similar light colors. We are having darker color here, and then slightly light here, and then lighter become here. So then this is what we have: the zone 5, then zone 3, zone 4, and zone 3 and zone 2. So you have the variation which goes on this side. And why this is in zone 5? Because there is an historical earthquakes which have been recorded from this region in 1668. There was a big earthquake, and then there was an 1819. There was a big earthquake. 1956 there was a large magnitude earthquake, of course, but not as large as what we experienced in 2001 Bhuj earthquake. So we have an record of couple of large magnitude earthquakes from this region, which were more than 7.5, more than 7.5 in this region. Hence we have this Kutch region is in zone 5. Then comes down to zone 4, which lies in the alluvial plain area, similar to what we see here in the Indo-Gangetic plain, like Bihar area, then some part of Uttar Pradesh, Punjab and all that, they falls in zone 4, close to the Himalayan range. And further, if you move here, we see again they are in the alluvial plain and all that. These are in zone 3, and then lighter yellow or whitish yellow area all is in zone 2. Okay. So earlier we were having zone 1, which was been removed. Okay. So as and when we keep on incorporating more data, or we are improving our database, then we keep on improving our hazard map also. Now coming to the another part, that is landslide, or we can say mass wasting. This is also important, but again, as I was talking about, that every hazard has its own specific geographic location. We cannot expect all type of hazard at all points. Okay, it is difficult because of the site conditions. Okay, and of course the feasibility, or we can say the that whether the site is ideal to trigger that type of events. Okay. So landslides are very common in mostly the hilly areas, and we know that the hilly tracts during the monsoon and all that will definitely face or we can say frequent landslides. And the areas in Asia Pacific region, mostly frequent landslides are experienced in India, China, Nepal, Thailand and Philippines. So these are in the areas where we are having the hilly tracts. So we will have more landslides in that particular area. Nevertheless, during seismic shaking, we experienced and we recorded a landslip even along the slope or the area which was having a slope of hardly 2 degrees. Okay. So that is also one important point which we should take into consideration, that landslip can also occur even if the land is having, or the area is having very gentle slope up to 2 degrees also. So landslides are aggravated due to the influence of topography by human activity. Now topography, as we were talking about, we would say that okay, if we are having slope, then this area is likely to have the slip, okay, if other conditions are fulfilled, like you have heavy rainfall, you are having weak zones or weak material lying sitting on the slope, okay, that are prone to the landslide. And when the landslide will occur, because if the sediments are losing their shear strength or the capability of holding themselves on the slope. The another is the deforestation. We keep on talking about deforestation. We also learn this at the school level, that deforestation is not good, but definitely if you keep exposing the slope. So, if you are having the slope full of trees, okay, and then vegetation, that what we will say, that then definitely this will help us in holding the soil over the slope. But if you remove this, then what you are doing is you are exposing the slope directly to the erosion, or you are subjecting the slope material to erosion, which will result into the percolation of the water as well as the loss in shear strength of the material. Human interference is deforestation and construction also. So, if human interference, for example, will be like you cut this area for the construction of road, then you are exposing this part further, you put more load on the slope, that also will result into the destabilization of the fragile surfaces. So, overloading by putting more construction material or dumping more material on the slope can also be the reason for triggering the landslide. Now, as a result of the combined action of natural, mostly heavy rain, and human induced factor, as many as greater than 12,000 landslides occur in India and Nepal per year. Now, this is just based on the your rainfall, okay. But if suppose there is an earthquake in this region, because both regions in the Himalayan side are prone to earthquakes also, and if there is an earthquake, then also the landslide will be triggered. So, landslide can be triggered in twofold: either it is because of the earthquakes or because of the heavy rain. And now recently, as I mentioned in the last month only, there was a landslide which was been triggered by volcanic eruption in Indonesia. So, landslides in Himalayas are also caused along active fault. This is what I was talking about. The active faults, when we are talking, we say that they are capable of triggering the earthquake, or they are the places where we will have the surface displacement will result. Then this is because of the ongoing deformation between Indian and Eurasian plates. So, these are the locations which have been shown, which are the areas in India which are prone to landslides, mostly in the hilly tracts. Okay. So, we have in northeast a lot of landslides have been triggered. This has been left out, but of course, this is a part of the Himalayan orogenic belt. So, we have landslides in Nepal and in this region also, and partly we see along the Konkan side. Okay. So, you will find lot of news during monsoon that this area is experiencing more landslide. So, this is because of the lithology, the rock type in that area, as well as because of the heavy rain. So, prominent areas of landslide in India. Map showing landslide affected states. So, darker green color is highly affected, the lighter one is moderately affected, and lightest is marginally affected. These are a couple of events, landslide events, which were been experienced since 68 to 2016 in India, landslide in Nepal because of heavy rain, Pune landslide in 2014, again it was subjected to heavy rains, and in Bihar also, as well as in Nepal in 2015 or 2014. This picture is bit interesting. It shows the effect of the material which moved down during a landslide or mass movement. And if you just carefully look at this, half of this house has been covered in debris. So, a lot of coarser material will be transported during landslide. And one example is from here, the boulder, huge boulder which was been transported or moved, and also the material which has been seen here comparatively finer than this one, but these are all cobbly bouldery material. This is an example of a mud flow which is termed as lahar, triggered by volcanic eruption. So, in previous lecture, one of the lecture I was talking about the lahar flow. So, lahar flow is a typical mud flow which is been triggered if you are having a snow or cap volcanic cones. So, when the lava is poured out on the area, then the snow covered will melt and will result into the lahar flow or the mud flow, which is termed as lahar flow. So, this occurred in 1985, which destroyed the town of Armero in Colombia. So, this is termed as a lahar flow. Okay. So, this you can keep in mind that wherever we are having the volcano capped by snow will result into the lahar flow when there is an eruption. Now, coming to the next, as a part of the landslide is the Kedarnath event, which occurred in 2013, and these two photographs which shows that how devastating it was. The temple remained intact. Either you consider that was because of the myth or religious effect. Of course, there may be, but let us not get into that. But yes, the temple did not face any issues during the landslide or the debris flow. Again, you can look at the size of cluster here. It's a huge, and one of the photographs which is not shown here, but we saw that in public domain, that a very large boulder which came and stopped behind this tower of the temple, okay, which was responsible for saving this temple. But surrounding the houses and shops and everything was been completely destroyed. So, this happened on June 15, and June is the month or this the month during one of the month during the season, the monsoon season. Okay, so heavy rains was one of the reason, but it was the cloud burst, so sudden pouring of the water, and more than 1,000 people were killed in this event. Now, the geologist or the sedimentologist, what they identified later on, that similar type of debris deposits were preserved in sedimentary sections, which clearly suggests that in past also this area experienced similar type of events. So, you can go into the past through the signatures which are available either at the surface, on the surface in form of some records in sediments, and try to reconstruct the history. So, this was been done, but this was done after the event, and people have been talking about, the scientific group has been talking about that there were similar type of events in the past also. Yeah, this picture is here, which shows that a lot of big boulders which came and stopped behind this tower and was responsible for saving the whole structure, but rest of the area was completely in mess. Okay. So, damage was severe because of sudden pouring of huge amount of water due to cloud burst, and which triggered in turn the debris flow. Coming to floods, floods are the most common climate related disaster. It includes seasonal flooding, flash floods, urban floods. Now, urban floods are mainly because of the inadequate drainage facility, and floods associated with tidal events which are induced by typhoons, cyclones in the coastal areas. So, inadequate facility of what? The question is that inadequate facilities of what? The inadequate facilities of drainage. We are talking about the drainage which is responsible to remove the excess water as fast as possible from that particular area. So, we can say the storm sewer or the natural sewer lines are choked. One may be one of the reason that it does not allow the flood water to flow through as quickly as possible, or we have come in between in terms of the urbanization. We have come on the way of the drainage which existed in the past. So, we have somehow blocked the flow paths of those particular streams and came up with constructions, or we are not having the good plan for draining out the water as fast as possible. Now, from June to September each year, monsoon in southern Asia is experienced. The rains are crucial for agriculture, but at the same time poses hazard to crop, homes and people. Floods often submerge fields, destroy buildings and contaminate drinking water. So, when there is no rain we cry, but when there is excess rain we again cry. Okay. So, these are the problems which are associated with heavy precipitation in any particular area if we are having inadequate drainage facility. Now, this just to show you that what is the scenario around the Indian part. We have the areas which are receiving very heavy like amount of rainfall, about above 400 centimeter, which are shown by dark blue color, and then 200 to 400 by lighter one, and then fluorescent blue 100 to 200 centimeter. So, a very huge area of India, and then comes down to even 0 to 20, which is of course in the area along the Thar region. This is Thar desert, the Rajasthan area. So, one can easily make out that the areas which are having very high rainfall or which are going to experience very high rainfall during monsoon will be prone to flooding, but it may be other way around. Okay. The areas which are having, like in this region, where one of the area is Delhi, which always experience flooding, the metro areas like Bombay, which always experience flooding, and many such metro cities are experiencing flooding even with slight higher rainfall or in that particular period. All are because of the inadequate drainage facility which is available there. Now, based on the rainfall and other atmospheric parameters, the areas have been divided into arid, semi-arid, dry. Of course, the arid area is the area which has which is likely to have or receive a very less rainfall as compared to the other area, and then the area which we were talking about heavy rains and the annual rainfall is very high are marked by the blue here and which are termed as pre-humid area, and then you are having a little bit higher than they are like less than that is humid and moist areas. Now, in India, regions like Bihar, Uttar Pradesh, Gujarat, Maharashtra are facing flooding problems every year. Now, in addition to that, since the last couple of years, if you look at like Rajasthan and Kutch region, okay, Rajasthan and Kutch region of are here, okay. So, Kutch region is in arid which receives less rainfall, okay, and then we are having the Rajasthan, again it is an arid or semi-arid area which receives less rainfall. They are also experiencing flooding. Now, most of the floods which were been experienced in Kutch and that is in area of Gujarat and Rajasthan were because of the heavy rain or sudden pouring out of the water in a very short period. Okay. So, the coastal areas are also having their own issues. So, again these are the maps which I was showing in the previous slides also. Most of the maps are from BMTPC. This shows the records of that what will be the wave heights and because of the either during the high wave, and then what will be the flooding conditions which may experience. So, these are the recorded wave heights along this area which have been given here in numbers. Now, this is a very good example from Gujarat. There was the flooding experienced in Surat. So, what I will do is this is a very interesting story and need more time. So, we will continue in the next lecture and discuss more about the man-made or human-induced flood in this part of India, that is a western India, Gujarat. The city name is Surat. So, thank you so much.